Assalamu alaikum students, I am Dr. Anila Azim from Physiology, and the practical for this week today what we are going to discuss is the simple muscle twitch. Now the principle for this practical is that when a single electrical stimulus is applied to the sciatic nerve gastrocnemius muscle preparation, there occurs a sharp momentary single contraction of the muscle which is followed by a relaxation. And this single contraction and relaxation in combination is called as the simple muscle twitch. Now what we are trying to learn through this practical is to record the response of the muscle on the application of the single stimulus on the sciatic nerve, and to learn the different phases of simple muscle twitch and the underlying physiological basis behind each phase. The requirements for this practical are a kymograph, a cylinder with a glazed graph paper, a dissection box for dissecting the gastrocnemius muscle of the frog, and linger lactate solution for pouring onto the nerve and muscle preparation. Now the procedure for performing this simple muscle twitch is: first set the apparatus, means the kymograph, attach the glazed graph paper with the cylinder box, switch on the kymograph, and dissect out the sciatic nerve and the gastrocnemius muscle preparation, and fix the muscle preparation in the muscle chamber with the headed pin, and tie the other end of the gastrocnemius muscle with the vertical arm of the lever. Now position the electrode assembly adjacent to the fixing pin, plug the electrode leads to output sockets of the simulator, and set the voltage. When ready to record, bring the ink stylus in contact with the graph paper. Make sure the switch is in the central position. Record the baseline, and to mark the point of the stimulus, bring the striker in contact with the contact switch and press the single button. To get the recording, select the speed at 625 millimeters per second, hold down the external trigger switch, pull it out, and then push it immediately back. So in this way you will get a simple muscle twitch on the graph paper, in which you can trace or mark a latent period, a contraction period, and a relaxation period, which I will explain in my next video. So this is the graph we are going to get when we will give a single electrical stimulus to the gastrocnemius muscle preparation. Here you can see I have marked a point of stimulus from where we have given the electrical stimulus to the muscle preparation, and from the point of the stimulus till the time comes that you see an uprise in the graph which shows the start of the contraction period. So from the point of the stimulus till the start of the contraction marks the latent period, which we are going to calculate in seconds. And from the start of the contraction till the maximum height of the graph you will mark as the contraction period, and when you will draw it on the graph paper you will count the number of the boxes for each period. Then when it starts coming down, it marks the start of the relaxation period till the point it comes again touches the baseline, and that is your relaxation period. So you will count the number of the boxes on the graph paper for the relaxation period also. Now the key for this graph would be that one box on the graph paper is equal to 6 millimeters, and the speed of the kymograph, as I have told you earlier, we have set it to 625 millimeters per second. As you know that the formula for the distance is speed into time, and we have to calculate the time, different time periods as a latent period, contraction period, and relaxation period. So we will take the time out. So formula becomes distance over speed, and distance here is number of the boxes which will be covered in each period. For example, 6 boxes in the latent period, and multiplied by 6 millimeter, as the each box is equal to 6 millimeter, which we will divide with the 625 millimeters per second. So it will give you the time in seconds. So in this way, you will calculate the latent period, the contraction period, and the relaxation period for the simple muscle twitch graph. And in the end, you can calculate the whole muscle twitch period by adding these three periods. Now, the precautions while performing these practicals are that while you are dissecting the nerve and muscle preparation, do not injure the sciatic nerve, and while you are performing the practical, do not let the preparation dry. Means you will be constantly pouring 0.6% normal saline, which is isotonic to frog's body, on your nerve and muscle preparation in the bath assembly, and do not apply traction too much to the sciatic nerve so that it is not stimulated by our electrical impulse. Our kymograph, I will introduce you to this apparatus. This is the kymograph, and this portion of the kymograph is called as the bath assembly because we put the gastrocnemius muscle and sciatic nerve preparation here in this, and we pour the linger lactate solution, which is 0.65% and which is isotonic to the frog body. The steps of the dissection will be explained to you or will be demonstrated to you when you will be in campus, inshallah. And in this season we usually don't have the frogs. This is their breeding season, so I don't have the actual nerve and muscle preparation with me. So these are the two electrodes. You can see once we put the nerve and muscle preparation here, we will fix the one end of the muscle with this pin. For example, here is the muscle. I will just fix the muscle by just pinching in this pin here, and the nerve, the sciatic nerve will be hanged here, and you can see that this is attached to these electrodes are attached to here in the kymograph, and this is the lever where we will tie the other end of the muscle, the tendon of the muscle. And you can see when I move this vertical lever, or when the contraction will happen in the muscle, this moves this stylus, and we will put in some ink over here. And when our all apparatus is ready, here you can see I have fixed the speed of the kymograph at 5, and this scale shows that 5 means the speed is 625 millimeters per second, which is our desired speed. And here are the different knobs or the buttons. It shows the voltage, and this is the button which shows the single pulse. We will press this when our apparatus is ready. We will just give the one single impulse to the nerve and muscle preparation. So once the muscle is fixed here, other end is tight with a cord here in the vertical lever, and the nerve is hanged on this electrode, and then we will take this stylus pin near the drum on the graph paper, and we will when we will start moving this, we will draw a baseline, and we will draw a point of stimulus here in this way. So we will give stimulus and we will give some reading here, and after that, when I will press the single pulse key, you will see when there will be actual muscle, there will be the contraction of the muscle followed by the relaxation period, and in this way we will get the graph as I have told you in the previous video. Thank you.